The topic I intend to talk about is a relatively wide topic. Today is all about color. The first topic is more on, in general, about color conversion and where you find the functionality in pdfToolbox and how exactly that works. I will probably spend a little bit of time on the convert color fixup, for example, which is a very powerful fixup but can be a little bit of a confusing one for people. And then the second part is really more of the same, where I want to focus a little bit on DeviceLink profiles specifically and how they relate to total ink coverage fixing and potentially ink save functionality. So it's all about color today. And like I said, those are complex topics. They are topics where we can probably spend half a day instead of half an hour. Let's get started. Your color isn't what it should be. So, as I said, what I want to talk about is color and color functionality inside of pdfToolbox. And there are largely three different ways to manage and convert color in pdfToolbox. That's what I always say during trainings. During trainings I have a little bit more time, but I'll try to condense that into this webinar. You have three main areas. The first one is ICC profile based, the second one is DeviceLink based, and the third one is everything that has to do with spot color and how you can change that. And to go into a little bit more detail before I take you to the product and we talk about this in the product as well, I have some schematics here. I'm assuming that some of you will be familiar with, for example, the difference between ICC profile-based color conversions and DeviceLink conversions. But I find, again, in trainings that this is often a sore topic or something that not everyone is aware of. So I will go over the basics very, very quickly. The first thing that you can do with pdfToolbox is a color conversion that is based on ICC profiles. As you probably know, an ICC profile is a way to characterize a color space, and you have ICC profiles, or you can have ICC profiles for very different things. You can have an ICC profile that characterizes the color space of your monitor or a camera or a scanner, but of course also output devices, printers and presses and so on. And in an ICC profile-based color conversion, there are always two ICC profiles that are used. In this example, it is sRGB as a source profile. So this is where we want to convert from. And then on the other hand, you have iso-coated V2 in this example, and that is a Cmyk-based destination profile. So that's where you want to convert to. And it's very important to realize that you always need two profiles. It will be very evident once we start looking at the convert color fixup, for example, that this really is a requirement. And many of the settings in the convert color fixup are there exactly to figure out what the source and destination profile are going to be in the color conversion that you're building. Now, what is essential in this is that each ICC profile really gives you a way to translate from one color space into a absolute color space, typically LAB, but there are other possibilities as well. And if you do a color conversion in this manner, then you will convert from the source profile sRGB into this LAB color space, and then we will convert from LAB into iso-coated V2. So you're not going directly using the orange arrow from one to the other. In fact, you're following these purple arrows and you're going through LAB, which is also called the profile connection space. And that is, of course, important. In an sRGB to isocoated V2 conversion, that's not really a big deal. But if you would use ICC profile-based color conversions to go from Cmyk to Cmyk, for example, iso-coated V2 to PSO-coated V2, or PSO-coated V3 it is actually, in that case, I will do Cmyk to LAB, LAB to Cmyk. And the result is that in many cases, the separations that you have, the pureness of some colors that you have, like primary and secondary colors, will be ruined by an ICC-based or ICC profile-based color conversion. Yeah? So for going from RGB to Cmyk, this is typically fine. Cmyk to RGB, same thing. But if you're going from one Cmyk color space to another Cmyk color space, then purely using ICC profiles in general is not going to give you the result that you're looking for or that you need. And in order to solve that, there is such a thing as a DeviceLink profile. A DeviceLink profile is an ICC profile, but a special one. In a DeviceLink profile, you actually have two ICC profiles or color spaces internally to that DeviceLink profile. What you see here on this schematic is a DeviceLink profile that goes from PSO-coated V3 to iso-coated V2. And the color conversion in this case does not go over this LAB color space. It goes directly from the source into the destination color space. The result is that you typically have a much better conversion. In a DeviceLink profile, you can embed all kinds of special rules. For example, you could say, if I have a color on the left-hand side in my source document that is pure cyan or that is pure red, a secondary color, then I want this DeviceLink conversion to keep it as pure cyan or to keep it pure red. Those kinds of rules, those kinds of exceptions are something that you can build into a DeviceLink profile, and as a result, for Cmyk to Cmyk conversions, you typically end up with better quality output from there. What is important though, and you already see that on this schematic, if I want to do color conversions and use DeviceLink profiles, I'm going to need a DeviceLink for each combination of source and destination profiles that I'm using. Yeah? So PSO-coated to iso-coated, fine. I can build a DeviceLink profile for that and use that to do a color conversion. But if my document also contains Japan-coated images, then I will also need a Japan-coated to iso-coated DeviceLink profile. For each pair of color spaces between which I want to do a color conversion, I need a specific DeviceLink profile that matches that particular source and destination color space. And then the third thing is a little bit different. As you know, next to Cmyk, we can also have spot color in documents, and then depending on what type of output process you have, pdfToolbox allows a whole lot of spot color specific functionality. And you can see the most important examples here on this slide. In the first case, I'm taking a spot color that is called spot123U, and I'm converting it, or renaming it is a better term, to spot123C. So the only thing we're changing is the actual name of the spot color. We're not really touching the actual color in the document, we're just changing the name of the spot color. Second example, the name of the spot color remains the same, but I am remapping the alternate color space that we have in the spot color. The alternate color space is what is used when you look at the spot color on screen. So when we change this, you will actually also see a different look. You will get a different view of the document on screen. If you then convert this document to Cmyk, or you print it on a printer that doesn't support spot color, you also in many cases will have a different print result. Why would you want to do this? Well, assume that a document contains brand colors, some kind of cola, for example. There is a brand color, and you know that to print these things, you always need a specific Cmyk mix for that color or a specific LAB mix for that brand color. Then this type of conversion allows you to do that. And then the third thing that you have in here is going from a spot color into a Cmyk color. And actually, I could have made this into a two-directional arrow because pdfToolbox supports both going from a spot color to Cmyk, but also going from a specific Cmyk mix into a spot color with a specific name. So both directions are actually possible. Okay, now enough theory about all of this stuff. So let me hide this for a second, and I'll choose one of my trusty pdfToolbox copies here. And what I can do, what do we start with? Well, I'm just going to open a document in here. So what I'm going to do is open a document, and I'm going to show you first of all in the switchboard what the functionality is that has to do with color. And remember the three things that I talked about before? Well, actually that is largely what you find here. The three different or the three main areas of color conversion that you can do. And then everything else that you find here is a special case largely of one of these other things. So the most important things are the first button here, process conversion, will do a conversion from one color into another color using ICC profiles. The third button here, DeviceLink conversion, does the same but using a DeviceLink profile. And then the second button here will do everything that has to do with spot color. Now, what I'm going to do here is I'm going to show you the spot color functionality first. Then we're going to go into a fixup, the convert color fixup, to look at all of the ICC profile-based color conversions, because that's the one typically that you would use for that. And then afterwards, we're going to look at device links a little bit more, but that also comes back in the second part of the presentation. So let me open a document to begin with that has lots of spot color, and we're going to go to spot colors in here. And what you can see is in the switchboard, I automatically get a list of all the spot colors in this document. Some of them are here, the real colors if you want. You can see that this document also contains a number of other spot colors, one for the die line, one for the fold lines that you have in here. I wonder if there is also a varnish still in here. No, apparently I didn't do that. But you have the full list here, and of course I can also check where they are used by going into the visualizer and saying, for example, visualize individual separations, and that gives me the same list of spot colors. I'm now looking at the sign separation, which is empty. I could look at the Pantone colors in this case that I have in the document, or look at the die line or at the fold lines that are in the document. So that's the visualization of those spot colors. But what I have here is a list that is actually editable. So if someone made a mistake with these Pantone colors, and they shouldn't actually be for coated paper, but they should be for uncoated, then I can change the name of that particular spot color. Or I could go in here and say, I don't want an LAB equivalent, I want a Cmyk equivalent. And maybe the Cmyk equivalent is wrong, and I want to modify that. So now if I say execute, it would convert that color from this yellow that I have in the left bottom half here into the much more ugly color that I have in the bottom. So I can change the name, I can change the alternate color space, I can convert that color into Cmyk, or I can remap it from this spot color into one of the other spot colors that I have in the document. And of course, applying it is always the same. So what happened here is that I did the conversion to Cmyk, but because I also changed the alternate color space, it did that conversion as well. And if I now look at the individual separation view, we should see, and indeed we see that one of these spot colors has disappeared, and that now I do have cyan, magenta, and yellow in there, because that spot color that we used for the background was converted into Cmyk. Yeah, so this summarizes quite neatly all the functionalities you can do with spot colors. Of course, if you're going to build this into a profile, what you would probably do in this particular case is go into the fixups and then create a fixup that you want to deal, where you want to deal with spot color. And you can search for spot here. That will show you all the functionality that has to do with spot colors. And in the libraries, you'll find lots of examples. I'm not going to go in all the details of this one. I want to save my time for convert color in this particular webinar. But if you go to the library called Prepress Color and Transparency, then you will find a lot of example fixups where different things are done with color, and many of them deal with transformations from spot to Cmyk, vice versa, spot to spot, and so on. So have a look through these fixups if you want to know what is possible. Now, where I wanted to spend my time is convert color, as I said. So I'm going to go into create fixup again, and then we're going to look for the convert colors fixup. And this is a relatively big fixup that consists out of two tabs. The first one allows me to define what the destination profile is, so where I want to convert to. The second tab will then allow me to specify for each color space in a document how I want to handle that particular color space, or for each type of object in the document. And we'll come back to that in just a second. We're talking about ICC profile-based color conversion. So remember that slide I had in the presentation. You always have a source and a destination profile. And the source and the destination profile need to come from the settings that you have here. In many cases, the source profile will actually come from the PDF file that you're converting, either from the output intent or from the objects inside of the PDF file. But the destination profile always comes from here. And in here you see all the ICC profiles that live in different parts of your macOS or Windows system, and I can choose for any of these ICC profiles. So let me be modern and go for a PSO coated v3 destination profile here. And this is going to be a little bit technical, but try to follow all these settings that you have. They are actually not that difficult, and I will explain the most important ones so that this fixup makes sense. So we've selected our destination profile, but the checkbox that you have here allows you to override that destination profile if you want. If I have a PDF document that contains an ICC profile as the output intent, this document actually does not. But if I have a PDF document that has an output intent, then I can tell pdfToolbox that I want to use that output intent instead of my destination profile. Now, in most cases, that probably is not what you want to do. You want to convert to a particular color space, and you don't want a PDF document that comes in from a client to dictate what that color space is going to be. So in most environments, I would think that this checkbox needs to be unchecked. your destination color space is always going to be PSO coated v3. Now, the next question is, once I've done my color conversion, what do I want to do with that PSO coated v3? I can do nothing, and in that case I will end up with a PDF document that does not have an output intent, or I can put that PSO coated v3 into my document, meaning every object that gets converted will get this profile attached to it. But in most situations, you would want to select the third option, embed as output intent for PDFX. The purpose of the output intent in a PDFX document is to say what the color is that you have in that file. So it is logical, if you convert to PSO coated, that you then also save that PSO coated ICC profile in the PDF document as the output intent. You've just converted into that, so by putting it in the PDFX output intent, you make sure that other people can see that that is the color space that you have in that particular document. So this actually makes the most sense in most environments. And then we come to the tricky bit. The tricky bits are these three profiles here. And this is what confuses many people, why we're specifying other profiles in here. Now there really is no mystery in here. Again, I'm going to go back to my slide. We're converting from one color space to the other. Our destination color space is what we set in the fixup. That's our PSO coated v3 in my fixup example. That's the one you see there. What is the source color profile? Well, you would expect that source color profile to be defined in the PDF document that you're converting. And that's possible. In a PDF document, you can have images that have an associated ICC profile. If that is the case, pdfToolbox will use the ICC profile that is attached to that image and use that as a source profile. Okay? But you can also have PDF files, and actually there's a lot of them that do not have ICC profiles attached to the content of that file. And if that PDF file also does not specify an output intent, then what is the source profile that I want to use? If I have an image but I don't have an associated ICC profile, pdfToolbox needs to know how to interpret that image. And that is what these assumed profiles do. If I have an RGB image or RGB content in the PDF document, but it doesn't have an associated ICC profile with it, then what am I going to assume that the source profile is? Well, pdfToolbox is going to assume it's Adobe RGB 1998 in this particular example. Whether that makes sense or not is something else, and I would probably say that in most cases it makes more sense to specify sRGB as the assumed profile. If we don't know what RGB we're getting, we're going to assume that it is sRGB. There's two reasons I select this. The first one is that sRGB is pretty, well, you find it a lot. You run across it quite a lot, so it's not a bad guess. And the second thing is that guessing that it's sRGB, even if it's not, is probably not going to be such a bad thing in the end. So that's a safe bet for that particular profile. The more important or more difficult decision is what we're going to do with Cmyk. The gray one is also relatively okay. If I don't know what it is, I'm going to assume something, and these dot gain profiles are not a bad assumption in those cases. But the Cmyk one could be a little bit more complex. If I'm receiving a PDF file from someone and it has Cmyk content, but that Cmyk content is not tagged with an ICC profile, what do I do? what is that Cmyk? Well, the obvious first choice is to check this. Output intent takes precedence over assumed profile. If you think that the people delivering files to you have put an output intent in their file that is correct, then you should say, yes, I want to use that one as the source profile. In that case, what pdfToolbox will do is it will first look at the output intent. If there is an output intent, it will use that. If there is no output intent, it will resort to the Cmyk profile we have there. And then you have a couple of choices that you can make. The first one would be to say, oh, I'm going to use something that is probably used a lot, something like isoquoted, for example. Or if I know where these files come from and what customer they come from, and I know that that particular customer always uses a particular ICC profile while it is preparing files for me, then I could, of course, select that one. That would make more sense. What I could also do is assume PSO quoted v3, which basically is the assumption when you don't want a color conversion to happen in this particular case. Yeah, but so the destination profile is the first thing that you define at the top, and the most important part in the rest of this is here these assumed profiles that tell pdfToolbox what to do if there is no embedded ICC profile for particular content in the incoming file. And then you have a bunch of other settings in there, and they are not that difficult, the ones you have here in any case. Use black point compensation. More and more that is something that is done, so but it's your choice whether you want to do that or not. Preserve black objects is if you have black objects in the incoming PDF document, black objects meaning pure black objects, then this setting will make sure that they are still black when you look at the output file. So you don't have this reseparation, as it's called, when you go from source to destination in that particular example. This is very similar to what I talked about for DeviceLink profiles, of course. The difference is that here I'm using an exception for black objects. In a DeviceLink profile, I can be much more intelligent than that, and I can look at black, but I can also look at pure colors like Cmyk. I can look at secondary or tertiary colors and have all kinds of special rules for these classes of colors. Here I can only make an exception for completely black objects. And then this one is interesting, but I'm not going to deal with the settings inside. On top of the settings that you can change in the user interface here, you also have something called an advanced conversion policy, a color policy, and that's a text file. You can actually see it if you go to open folder with configuration files. So if I do that, I get a folder with these files. They are called .cfg, but if I open one in a text editor, you'll see that, well, here you'll see that they are simply text files. They're actually tab delimited text files, and they allow you to set all kinds of much more complex parameters that are used during the color conversion. Now, like I said, I'm not going to spend any time on this, but what I do want to do is, if I go to the Kala Software website, I want to point out that if you go to support and then to online documentation, you'll end up on an online documentation site for the for pdfToolbox and the other products. If you go to the main documentation, the first link here is an overview manual. The main documentation file has a complete chapter on color conversion, chapter 4. And if you open that, you'll see that there is, well, what I'm talking about here for convert colors is detailed here, but you also will find a complete chapter on these color conversion files with all of the settings that are available in those policy files. So that can help you to figure out if the color conversion doesn't do exactly what you want. One of these advanced properties might actually be the trick that you're looking for. Go to the website and look at online documentation, or go to help.callussoftware.com. Like I said, it's the 4th chapter in the documentation for pdfToolbox itself. So what we've done meanwhile is we've defined our destination, we've defined what our source profile is going to be. Now we have to determine what is going to be converted. And here, when you look at some of the example color converts fixups that you'll see in pdfToolbox, there is probably going to be a list. The reason for that is that what typically happens is that you treat different types of color spaces in a different way. And I'll give you a very good example. If I have a uncalibrated Cmyk, which means Cmyk without an ICC profile attached, then I might not want to do anything with that color. So I can set that to do not convert. That's one option. If I have calibrated Cmyk, which means a Cmyk object that has an associated ICC profile, then I could choose to simply decalibrate. And decalibrate means take the ICC profile and throw it away. But if I'm looking at RGB, so if I go look at uncalibrated RGB, for example, which is RGB without an ICC profile attached, probably what I want to do is convert to destination. Okay? So in this section, once you have set up what your destination and what your assumed profiles are and so on, once you've done all of that, in this section you can specify what needs to be converted and what you don't want to convert, and just leave alone. Yeah? If I want to convert all RGB colors, but I don't want to convert anything that has to do with Cmyk, well, then I only need to specify something to tell pdfToolbox what to do with RGB, but I don't need to specify the other stuff. I can, of course, make it very simple for myself and say, well, actually what I want to do is I want you to take any color except for a spot color and then convert that to destination, for example. Keep in mind that if you do something like this, you will also do a Cmyk to Cmyk conversion using ICC profiles and not DeviceLink profiles. So the result of this might not be what you want or what you're looking for. You can do this in a little bit more fine-grained fashion. Here it will take everything with a particular color space and then determine what is going to be done with that. But I can also use this objects pull down. And here I could, for example, say, well, if I have a Cmyk object, a Cmyk image that is set to overprint, this is a pre-flight check that lives in my library, so I can use that. Or maybe I want to do something just for color images. Well, as soon as I select something here, this color space pull down is now disabled because the selection is done by at the object level, if you want. And now my color conversion will convert all color images. Yeah? So you can be pretty flexible with this, and you could make a color conversion that only looks for RGB images of a certain size, or RGB images that have a certain ICC profile attached. Or you can be as creative as you want, and just remember that you can either do a color conversion for a particular color space by using the color pop-up menu, or you can do that for specific objects, and you have some default selections that will always be there. You can do it for specific objects by using the object pull-down menu. Yeah? But the end result is always going to be that whatever gets selected here is going to be converted to the destination color space that you've set up in this particular section. There's much more that you can do with color conversion. I've picked out the convert color fixup to focus on, but there are definitely more things that you can do. I'm going to stop here. If you have specific questions, don't hesitate and put them in the questions box. But I'm going to close this, and I'm going to look a little bit more at DeviceLink profiles for the second part of this conversation. So let's go back to my presentation. I have to keep my timing a little bit at least. So if I go back here, now the object here, or the subject here, is Inksave, as it says here, but it's actually a little bit wider than that. The topic here is DeviceLink and what you can do and how you can do things with DeviceLink profiles. Inksave happens to be a question that we get relatively often in support. And there is something that we need to say preceding this talk about DeviceLink profiles. The main reason in most cases that people end up having to think about DeviceLink is because they look at total area coverage detection, or otherwise said, how can I figure out that a particular PDF document contains too much color? That's a very common check. And there are two conditions in pdfToolbox, and I wanted to start with that because it's a little bit confusing, and you actually have to do the right thing or you're completely not going to get what you want. The original condition, and a condition is something that you use while building a pre-flight check, the original condition in pdfToolbox that was available is called total amount of ink for fill or for stroke. If you go look in some of the Gantt group profiles, even the ones that are used today, the 1v4 profiles, then you will still find reference to a pre-flight check that uses that particular condition. What does it do? Well, it looks at the fill color of an object or the stroke color of an object, and it looks at whether that particular color uses too much ink or not. If your limit is 300%, then it will look at the fill color and say that if the ink mix for fill is more than 300%, we're going to give an error. But this is on an object per object base, which of course is not good. If I have an object that uses 220% ink and another one that uses 180% ink, and I put those two on top of each other, depending on which inks are used in both objects, I could well end up over 300%. It is the combination of all objects that should be checked. And actually, the condition that is called effective ink coverage in pdfToolbox does exactly that. It renders the PDF document, so for each page it will create a rendered image, and then it looks at that image and determines whether too much ink is being used or not. This is a slower test than the first one, but it's also a much better test, and this will give you the good result on whether a document contains too much ink or not. Yeah, so that's the one that you should use. Now, why was this first condition there? Well, there was a time that I somewhat remember where computers were much slower and where the calculations that were needed to do this type of rendering of a page and then figuring out what the ink usage of the different areas on the page was, where that was simply not possible and not available in any of the pre-flight tools at that point in time. And this first condition, total amount of ink, was the best thing that we could do at that point to do some checking of documents. But now, this day and age, you should use effective ink coverage. You have some variations. Have a look at inside of pdfToolbox. You'll see some variations. You can check ink coverage in a particular area, which is a really cool idea if you want to see whether something has ink where it's not allowed to have ink. You're printing envelopes or labels, for example, and you know that at some point later in the workflow, a barcode is going to have to be printed in a certain area of that file. Well, this effective ink coverage in a certain area would allow you to check the area where the barcode is going to be printed, and it would allow you to see if any design is specified there, or whether that part of the design is completely blank. And that can be an important decision to know whether that design is good or not good. So that is certainly very useful. There is also a variant that lets you specify certain separations. So you could say that you want to look at the ink coverage in cyan, but nothing else. Or you want to look at the ink coverage in a particular spot color, for example. If the ink coverage for the spot color called dye line is 0, then probably there is no dye line specified in the document. So sometimes you can use this check to check for things that strictly do not have anything to do with is there too much ink in the document to produce it correctly, but that can be used to answer other questions about this, the suitability of this document. Just keep that in mind as well. Now, what follows from this is the question, how do I fix that? If I have a document where the ink coverage is too high, how can I actually fix that? And what you'll find is that the only really good fix is using a DeviceLink profile, because the DeviceLink profile looks at the whole document and it will do a color conversion of all the objects in that document to a different color space, and that can be used to reduce the amount of ink while you're doing that. Now, what do you need for this? You need two things. You need a DeviceLink profile, and you need an engine to run this DeviceLink profile. Yeah. The first thing is not something that you can do with pdfToolbox. You can take a DeviceLink profile that already exists, or you can make it with some tool. An example of such a tool, and of course I'm not objective in this because we work with ColorLogic, so I'm going to use them as an example here, but an example of a tool that can make a DeviceLink profile to do tack reduction or to do ink save is ColorLogic Copra. That application allows you to say, what's the color space that I have in my document and how much ink do I want to reduce, and then it will make a DeviceLink profile for you. You can also use, and that's actually not a bad thing to think about, you can also use what ColorLogic calls DLS, which stands for DeviceLink set. And that basically is a set of pre-made DeviceLink profiles, which has an advantage. It's less expensive than buying Copra, but more importantly, you don't have to understand anything about making DeviceLinks because ColorLogic has already done it for you. So a DeviceLink set allows you to say, well, I'm working in commercial print sheet fat, for example. I'm going to look at the DeviceLink set for that particular printing system, and in that DeviceLink set from ColorLogic for sheet fat offset, for example, you will find standard conversion DeviceLink profiles. How do I go from ISO-coated to PSO-coated, or how do I go from a swap file to an ISO-coated file? But in those DeviceLinks, you will also have tack reduction, and you will have ink save profiles. So the advantage is you don't have to create them yourself, you simply use that DeviceLink set. And then you need an engine to run that DeviceLink profile. And depending on what your capability, or not your capabilities, what your needs are, you would look at something like, again, from ColorLogic, Zebra is the color server application that they have. Or you could take those DeviceLink profiles and run them in pdfToolbox desktop or server. That would be the second option. So let's see in pdfToolbox where you find this technology. And again, I'm not going to go into all the details because we're already spending quite a bit of time on this, but I want to show you where you find the functionality. And I'm going to start by opening the switchboard again. And in the colors group, you have this DeviceLink conversion tab. And if I open that, you can see the list of DeviceLink profiles that is available at the moment in the library that I'm looking at. So if I go to let me see, what do I do so that I don't mess up things too much. So if I go to a different library, I could say import, and then when I have one of these DeviceLink profiles, I'm using as an example a profile to go from ISO-coated to PSO-coated. This is actually a profile that you can download for free from the ECI website. So when I select that and I say open, it is going to be imported into my list inside of pdfToolbox, and then in my list I will have that DeviceLink profile that allows me to convert between those two standards. And once I have that, I can use that on a document. So here I have a profile that goes from ISO-coated v2 to PSO-coated v3. The document I have open uses an ISO-coated v2 profile. So if I say execute, it will run that color conversion on the document that I have open. And you see some color shift here, which is normal. These two profiles are different. So the colors in the document are modified so that if they are printed, the final printed result hopefully is very visually similar to my original document if it would be printed using a ISO-coated profile. Now, what you'll notice is that I did that conversion, so ISO-coated to PSO-coated, but I no longer have an output intent in my document. It had an ISO-coated v2 ICC profile as output intent. I did a conversion here to PSO-coated, but the only reasonable thing that pdfToolbox can do at that point is delete the output intent because it's sure that it is no longer valid. It cannot automatically insert the profile that we have used here because that profile is not an ICC profile, it's a DeviceLink profile. Yeah? And a DeviceLink profile cannot be used as output intent. We need a regular ICC profile for that. So what I could do is, and let's see if I find it from the first try this time. Yes, amazing. I can go to prepress, and under prepress I have something for output intents, and there I could say select the PSO-coated v3 profile. I want this file to be PDFX compliant, so I'm going to choose PDFX here, and I'm going to run that on here. Now, remark that this does not make the complete file PDFX compliant. I would need to do preflight for that, but it has inserted the profile that I wanted, the PSO-coated v3, in my document as a PDFX compliant output intent. Yeah, but this is where you find this functionality in the switchboard. You have under the colors group, the DeviceLink conversion option. You can import DeviceLink profiles and then you can run them. If you go to fixups, it is actually pretty straightforward. In fixups, let me search for DeviceLink, and then you have a fixup that is called Convert Colors Using DeviceLink Profiles, and lo and behold, that converts colors using the DeviceLink profile that I select here. Again, you see the whole list. This is that DeviceLink profile that we imported previously that goes from ISO-coated to PSO-coated. And again, I can specify where I want to apply that DeviceLink profile. Keep in mind that this will always go from ISO-coated to PSO-coated, so it will only do that conversion. And of course, because this is a fix-up, I can add as many other conversions as I want in here. So if I think that in my file I'm going to have Japan color objects, I can convert them to something else. If I have a bunch of profiles, DeviceLink profiles that convert to PSO coated from different source profiles, it might make sense to have a whole bunch of these profiles in here. Okay, so I think I am going to leave it at that. Let me bring up this presentation that we were dealing with again and summarize. And meanwhile, if there are still questions that are not answered yet, feel free to enter them into the question box that you have in GoToWebinar. Now, what we looked at is color conversion in general, and we talked about ICC profile based, DeviceLink based, and spot color based color conversions. We spent quite a bit of time on this ICC profile conversion using convert colors, which is the main fix-up for color conversion from one color space into another. And then in the second part, we also spent some time on not just detection of ink coverage and what you should do there, but on the fixing of that particular problem. And for that, you would need a DeviceLink profile. I've shown you in the switchboard where those DeviceLink profiles live and where you can import them into pdfToolbox. And then we also looked at the convert colors using DeviceLink profiles fix-up that allows you to do that color conversion as part of a profile. Maybe I need to add one last little thing on these DeviceLink profiles. When you start looking at tools that can create DeviceLink profiles, you should be aware that some of these tools can generate two different types of DeviceLink profile. An open one and a protected one. That is certainly the case with ColorLogic. A protected DeviceLink profile is a very good profile, but it will only run in the ColorLogic tools themselves. So you can make it with Copra, and then you can run it with the color server application, Zebra, but you would not be able to use it in pdfToolbox. If you would do that, you would end up with very, very strange colors, and that's because of the protection. With Copra, you can also create open profiles, and an open profile is, well, open. So that one you can use in pdfToolbox. For these DeviceLink sets that I talked about, and maybe I will just show you that. If I go to ColorLogic, and hopefully I end up on the English version. Perfect. So if I look at products, you have Copra and Zebra that I talked about, but there is also this DLS product, and that is a list or a collection of optimized device links. And those device links, you see all the different sets that exist. So for example, if I do SheetFed, then I will get a set of DeviceLink profiles that do conversion, tech reduction, and ink saving for that particular market segment. So this contains the profiles that you need for this particular market segment / printing technology, and you can see all the different sets that they have available. There is an expert set that is really the union of all these other sets together, so that has all the profiles in there. If you have questions about that, or if you have questions on how to use that together with pdfToolbox, then don't hesitate to ask us as well. We are not only distributing the Callus software products, we are also distributors for these DLS products, and in some areas, not all areas, but some areas also for the other products that ColorLogic has. So if you have questions, just get in contact.